Oh, funny story over the weekend, I suppose. We've been messing around with some new resin 3D printers, possibly looking at printing masks on those, or is there a higher definition and be less porous and things. And I got the first test print on this one printed out fine. It was really nice. And actually, we can I can show you the result here. Then I had about 10 in a row that I couldn't get to stick. Kept making changes. So here's Baby Yoda. I can't get him off the plate. So for 10 in a row, I couldn't get him to stick to the plate. And now I've been using a crowbar and a hammer and all this stuff. I can't get him off the plate. So that'll be this afternoon. But Yoda looks really nice. It's really printed out and printed out beautifully. So yeah, that'll be this afternoon's project. I look forward to completely breaking that model probably. But that is funny how it goes the other direction. You know, I can't get anything to stick and then it sticks too well. Because this technology, it like lowers down into this vat of liquid resin and then it lifts up just a little bit at a time and cures the surface of it. So then you get this like drippy thing afterwards that you need to then put into ultraviolet light to finish curing. And he just kept falling off the plate into the vat of goo. But it is what it is. So I'll figure there's probably some setting in the middle there where it wasn't sticking and now it is sticking too well. So I probably have to just back off a little bit. That's once I get him off the plate. All right. So let me bounce over here. All right, so what we had done for today is bring our game back to the state it was from a couple of assignments ago. That is with our player being able to run around and the rat in there and us being able to attack. And hopefully you saw that that was not really a big deal because we didn't change anything other than the way we were building our rooms. A room was still a room. We were still, an inhabitant was still an inhabitant. You just needed to change the way that they would have gone between rooms, and we'll swing back into that. Actually, what I can do here is let's look at that here. Roll up a little. Let's see. Have the. To look around the dungeon. Okay, that was before the kill. Working attack code. All right, so I'm going to steal that code from there. And then we'll paste it into our project here. So last time we generated the map, we displayed the map in, you know, some sort of way. I don't remember what we did to display the map. No, the map just goes through and displays all the rooms and stuff like that that are in there. All right, so now what I'll do is paste our old code in there. Now our old code created a player, and then they added the player to this thing called R1, which used to be room 1. Well, now we need to ask the map to actually add our player into a room with a name. So let's go up to our map. So here's our map builder. And if you remember, map builder maintains a collection of rooms and a collection of exits. So, and a collection of rooms now has a room has an ID, a room ID. So we want to go through that collection of rooms, looking at the room IDs, finding the room that has the ID we're trying to add the player to, and then adding the player to that room's list of inhabitants. So what we're going to do is we're going to build a function into our map builder. This is map builder. This is map builder. All right. And we're going to say def add player. And this is going to take in the player we want to add and the room ID to which we want to add them. All right, so we're going to go and search through our collection of rooms. So for a room in the collection of rooms, we want to ask a question. We want to know if the room we're looking at has a room ID that's the same as the room ID we're looking at there. So if a room dot room ID capital. If a room ID is equal to the room ID we passed in, if those two equal each other, then we have found the room that we want to put the player in. And we already have the, well, why isn't my completion thing working here? We already have the ability in a room to add a player. And that'll add the player to the room and set the current room to that, set that player's current room to that guy. All right, so we'll say add player. The player we're going to add is the player that was passed into this function right here. That'll add him to that room's list of inhabitants and set player's room to that room. Now we have finished adding this player. So we'll go ahead and break out of that loop. Player has been added to the room. Now, similarly, we want to be able to add a monster. And we'll call it add inhabitant. This could be any kind of inhabitant to a room ID. And we'll steal we'll steal all that code. We're no longer adding a player. We call it add inhabitant, or we call it add monster. Well, we called it add monster. That's fine, at least for now. So we're adding a monster for this one, and he is inhabitant. And then we'll break out. All right, so what we've done here is we've changed the way that we get players and monsters into our game. So before, we created the player and then we told the room directly to add the player. But now what we want to do is we want to ask the map to add this player to the room with ID. I think we used capital letters, yeah. So R1. Like that. So we want to add this player to this room ID. Similarly, we'll, I don't think we have the full, I just have room 1 and room 2 right now. So I'm not going to build out the rest of our map yet because we're going to look at a better way of doing our map today. So I'm going to avoid the dragon for right now. And we will, the map, add monster to R1. So that should add those 2 guys there. And then we go back and forth over and over again, asking the player, what do you want to do? If we say look, it spins back up. If the command is kill, we get into the fight with the inhabitant of the room we're currently in. Else, we try to take an exit. And taking an exit from a room currently works a little bit off. So let's go up and look at our take exit. Oh, and by the way, I did remember to go and try to adjust my scroll speed. As far as I could tell, there isn't a way to adjust the scroll speed, at least not through a graphical thing. So I had to look at it at some sort of script level or something. But I did, upon second reminder, did actually go and try to do it. But it's still not fixed. All right, so we're going to be taking a exit. Who's going to take the exit? In this case, the player, and we're going to take it in a certain direction. So we're going to go through our list of exits, asking if the exit has a direction associated with the direction we want to go. We'll go ahead and remove the player from the current list of inhabitants. Now, what we do need to do, though, is before we can just get the room destination for that exit, that room destination, we have to look up the exit inside of the, we have to look up the room inside the map to find the room that's associated with the room ID of the exit. If you remember, we updated exits to now, instead of holding a room, it holds a room destination ID. All right, so when we, and again, we add and remove players and inhabitants through the map now. So the map is the guy who knows about all our exits. He knows about all of our rooms, so on and so forth. So we're going to add a function to our map that allows us to find a room given its ID. I don't think we wrote that yet, right? We have build room, we have build exit, we have display. Okay. So we'll say def get room given room ID. All right, so we'll pass it a room ID. He's going to search through his collection of rooms. So for a room in self dot collection of rooms, if a room dot room ID is equal to the room ID we're looking for, then we'll return a room. So look through my collection of rooms. Each time through, a room will be one of those rooms. We'll ask, is that room's room ID equal to the room we're looking for? If it is, we're going to return the actual room. All right, so now down here, when we try to take an exit, we're asking the player to take an exit from his current room. Now, what that needs to do is that's going to, well, a couple different options here. We can let that guy know about the map. So, because this take exit method, it's going to take in the player and then the exit direction. This is our direction, right? And it's going to have to look up the room associated with that particular exit direction. So we can come in here to, so here, just for the time being, I'm going to pass it the map, because he's going to need to know about the map in order to look up all those things. The map is our key that holds the entire world together. All right. So for that particular take exit function, I'm saying the player is going to take the exit in this direction. And by the way, here's the tool you're going to need to look up the actual room given the room ID once you get the room ID from the room he's currently in. So now that I have the map, let's go up to take exit. All right, so now we get the map as another parameter that comes in here. So because we passed it to this guy. And there's some different approaches you could have taken for how to access the map, but we're going to just pass it around whenever we need it. All right, so we're going to go through all the list of exits in the exit, looking for a direction that matches the direction we're looking for. But now we need to actually get the room associated with that direction. We don't have a room destination anymore. We now need to get the room using the map. So we're going to say, we'll say destination room. We'll set a variable equal to something. We're going to use the map to look it up. And what did I say? Get. It would be really nice if that completion thing works. I think I said get room given room ID. Yeah, this guy. All right, here's our take exit. So this is called get room given room ID. And the room ID we are going to is called an exit dot. Actually, isn't it called destination room ID? I think it's called that. Let me confirm it though. Nope, room destination ID. All right, so I'm gonna ask the exit to give me the room destination ID. So that's the unique ID for the room. Then I'm gonna ask the map to get me the actual room given that ID. And he'll give me that room in this variable called destination room. All right, so then once I have destination room, we'll say, we'll go ahead and remove ourselves from the current room. Then we're going to be adding the player to the destination room. That's what it means to add the player to that destination room. Look up the room, given its ID. That's the thing we had to change. Remove ourselves from the current room. That didn't have to change. And then put ourselves in the destination room. This also did not have to change, other than the fact that the way we accessed the destination room was different, because we only had the destination ID and we had to use the map to look up the actual room given that ID. Okay. So that's for take exits. Let's make sure we're compatible with our other stuff here. Build the map, build the player, add the player to the room ID R1, build the rat, add the rat to room ID 1, then go into our loop where we ask the player for some stuff. We'll ask him to display the current room, read in a command. If he types quit, we get out of there. If he types look, we just zip back around and show him the room again. If he types kill, he gets into a fight with the monster. So I don't think that has changed at all. Otherwise, we take an exit. There's no attribute called add monster. Oh, it's called, I called it add inhabitant. You know what? Just so we stay consistent with what we've written elsewhere in our program right now, let's just call it add inhabitant, or add monster rather. Just because we called it monster someplace else, even though I've been generically referring to it as the inhabitant. Okay, so we're in room 1. Mr. Gonzalez and the rat, what do you want to do? I'm going to go ahead and go to the north. So that took us to the north. So now we just saw our exits working differently because it actually had to look up the room given its ID. Now we have an exit to the south because remember, I only have this simplified 2-room map right now. So we'll go back to the south. I'm here. There's the rat, what we call a kill rat. The rat has died. Okay, although the corpse is technically still in the room. All right, so I think that's the solution to the homework for today, although I think I also told you to finish building out the map. But, you know, whatever. If you didn't build out the map, that's not the end of the world, as long as you've updated our code to now be compatible with this whole room ID for an exit thing. All right, so questions about that? Go ahead and paste this into Slack. Where's my code shortcut? Code or text snippet? All right, so now I want to go back and look at our map text. A couple of things we look at here. On one hand, we have, this is pretty easy to read for a human being, but some limitations we have on this. Well, I'll just ask the group first to get a little interaction going. What are some weaknesses of my current file setup? Or constraints. Maybe you want to think about them as constraints instead of weaknesses, that's okay. Anybody have any suggestions on what might be wrong with this?
It's fixed on what you can do.
Okay, so it's fixed on what you can do, and probably more importantly in this, the order in which you have to do it, right? So
Yeah.
we expect title to be first. We can't give it the description first, otherwise that's going to flip-flop our title and our description. All right, so the way we are, we've built this, it works. This is probably still friendlier, right, than writing all the tedious syntax for creating your individual rooms and stuff like that. So this feels like, a human being could be a little bit more creative if they're operating with it at this level than dealing with all the little syntaxes for creating instances of rooms and things like that. But we still are having to play by a very strict set of rules here. That is, we have to give the title first, we have to give the description, then we have to give the ID, then we can begin giving exits after that. We can't do those in any order, and things need to be very careful. If you remember the bug we had a couple classes ago, that just broke it, because now it thinks we're going to another room and there's nothing there. So this whole document is very set in its ways, and that could give us some limitations, or at the very least give us some strange bugs where, you know, you might be sitting here looking at your syntax throughout this whole thing, and by me just putting that enter there at the end, now my map is broken. As opposed to if I just take that one thing off the end there and save, now it works again. So that's like a tedious little problem that, you know, we wouldn't have necessarily thought that much about, but it's a, you know, a legit issue. All right, so we would call this adequate, but not necessarily perfect. Another weakness of this guy is, remember we called these, we go back to our notes here. We were talking about data representation languages. All right, and so the idea is like, okay, we decided, okay, we have a map that we want to represent here. And because of that, we're going to go ahead and we're going to invent our own little language for describing a map, just because. All right, so now because of that, you know, we went ahead and we decided, okay, well, our map looks like, our language looks like this. You know, this is how it's just going to be. Now, if somebody else wanted to use our format for describing a cave crawler or something like that's going to be real popular, but let's just assume it is, you know, they're going to have to go and learn this language. So if you go and travel to Italy, you're going to have to learn the Italian language or rely on them to speak the broken English or whatever. So, you know, you could either require somebody to go and speak the language of the destination for every new destination, or we can have kind of this universal language, which I guess in the real world that has kind of become English, but probably against, you know, some other countries' wishes, but it is what it is. But, you know, in any case, you know, having kind of a universal language that just works everywhere, and then people can pull meaning out of that language. And that's what we're going to jump to today, is we're going to say, you know, our little invented language, it got the job done. It worked. It meant something to us. It should. We invented it, right? But it had some limitations. It required us to fit into the, you know, we had to have that mold sitting there where the things had to be in just the perfect order. If I flip-flopped a couple things, it broke. If I had an extra enter statement, it broke. So it was right on the precipice of being unwieldy. But because we invented it, we were able to wield it reasonably. Now, over the years, we've had some different approaches to data representation languages becoming more and more universal. Now, I'm going to realistically call XML and JSON legitimate competitors, although the current cool kid is Json. And that's the one we're going to look at today. And we're going to see that it's actually pretty friendly. So for us, let's actually just jump over here. I'm going to create a second version of this file. So we're going to create a new. I'll save this. I'm going to call it the map.json. I'll just give it an extension. It doesn't have to be called .json, but I'll give it an extension .json, which will remind me that I intend to have JSON stuff in there. I'll go ahead and paste my map in there for right now. And we're going to translate this into a JSON object. Now, the way JSON works, first of all, anybody know what JSON stands for? I might have mentioned it in class already. Okay, it's going to be very compatible with what we need, which is why JSON's become so popular. This is JavaScript object notation. That is, this is how the JavaScript language represents its objects. So we're thinking about representing map and room and exit objects. And doesn't it make sense to use a scripting, a data representation language that was specifically designed for another programming language to represent its actual objects? It used it internally in the language in place of this stuff. It represented its objects as, we still needed the logic written after that, but it represented its objects behind the scenes in this format where we have something called a room, where a room has a title, a description, and a room ID, as well as a list of exits and a list of inhabitants. It needed a way of representing the object itself and the fields associated with that object. All right, so going back over here, if we're going to convert here, let's just think about what does a room look like. So JSON uses opening and closing curly braces to hold on to its objects. All right, so this is an object value. Object value is an opening and closing curly braces. A collection value is opening, I'm going to put a little space in between these just so they're a little bit more distinguished, is opening, closing square brackets, kind of like a list, right? So these are looking very programmy. So an object value holds something like this. A collection value holds something like this. Object values hold things that are name value pairs. So for instance, if I had first name, Mike, last name, Littman, age, 21, that would be a example of a JSON object, a JSON representation of an object that has a first name, a last name, and an age field. First name is a string, Mike. Last name is a string, Littman. Age is a number, 21. What does this guy look like to you in the Python world?
A dictionary.
Dictionary. All right, so dictionaries came from this idea. So dictionaries actually are in JavaScript or in JSON notation, JavaScript object notation. All right, so let's go and let's see, I'm going to do it here in file test. I'll just take over our file test thing here since we have our code in the other thing. So I'm going to go ahead and we're going to say object is equal to that, and then we'll say object at bucket f name equal to Mike, object at bucket L name is equal to Littman, object at bucket age is equal to 21, and then I'll print out object. And we see we get JSON. All right, so this has already been something we've been working with. All right, so now what would be nice, and I'm going to, I'm just going to save this for now. I'm going to create a new file. We'll call this guy object test.json. Okay, now I'm going to go ahead, I'm going to steal this, paste it in there. All right, so I'm going to read that guy, or just store that guy in that file. So this is like our input file. Now, back out here in file test, we're going to import a library here called Json that knows how to work with Json. And I brought up some documentation here. So we import Json. We can work with it directly. So, well, actually, I'll just do this. So I'll go ahead and steal. We'll say X is equal to that guy. And that's going to be as a string. And then we're going to go ahead and say Y is equal to JSON load S of X. Close the double quotes on one. Or does it not like? Yeah, it wants it as a, I think it wants me to represent it like that. But I think it wants these to be in double quotes. Here, let me just test it, make sure it still breaks. Yeah. Because we use Python's output for this, it used those single quote things. All right. So Python, if inside of it, it wants you to use the double quotes. And then outside, you can use the single quotes to say, this is a string. And then these are the name value pairs inside of these. I tend to use the double quotes everywhere. And I don't think that will work either. Yeah. Because the issue here is that if I used it as a, was it a raw string? Like a raw string. Isn't that the, wasn't it R before it for raw string? I think so, but it's still breaking on the double quotes there. See, the issue here is it thinks that, here I have an opening double quote, it thinks this is the corresponding closing double quote. But raw strings, I thought, are supposed to fix that. Let me just quickly look up. If you remember raw strings from us dealing with regular expressions. Ay, ay, ay. Oh yeah, it works for the other stuff, just not for the double quotes apparently. Oh well, is what it is. So for right now, if we're dealing with JSON surrounded by single quotes and then have double quotes on the inside, and it'll be happy with you. There might be another way around it, but deal with that for right now. All right, so I can have a single input like this. So this is just, I'm not reading it in from a file here. I just given myself a string that's in JSON format. And then I use the JSON library to load that string. So here's the string I passed in there, and it gave me a dictionary. So if I say Y at first name, it'll give me the mic. So the output of load S is a Python dictionary. Now notice here, I can switch first name and last name around there, and this guy still works because the order in which these name value pairs occur inside of the JSON is not important as long as they're part of the JSON object. Okay, I still get that dictionary and I still say, give me the value of first name in this dictionary, wherever it might be. All right. Now, the JSON library also has the ability to read in from a file. Oh, this is another, we have a thing called dump s too. So here's my object. When I print out this object up here, it's showing me something that looks like JSON. But if I were to try to concatenate onto that an LOL, it's saying you can't concatenate onto a dictionary a string. So this guy is still structurally a dictionary. But now if I say JSON.dumpS object, and we call this guy JSON string, and then I print JSON string, we see that we get the same thing displayed twice. But the second one, oh, I put an underscore, not a plus sign. The second one is a string, not a dictionary. That makes sense? And you can actually see that it did update the format a little bit to do the double quote stuff. So dump s takes a dictionary as a parameter and gives us the string representation, the JSON string representation of that dictionary. All right, so let's add that to the notes here real quick. Python JSON library. We have load_s brings in a string and produces a dictionary. Then we have dump_s. This brings in a dictionary and produces a string. All right, so we have a tool that lets us go back and forth between those two guys. And lastly, we do have the ability to read in from a file directly, although we can still use our read. We could use our current thing that brings in a big string. But there's a way to do it directly. Oh, it actually reads it the same way. It opens the file, and then we just pass it the file. So I'll demonstrate that here real quick. So we had our file test. So we just go over to homework 1, because this is where we actually open the file for our map builder. If I go to the constructor for map builder here, I open up my file here. So here I'll even steal this line. And we'll go over here to file test. And the name of this file is what I called called it object test.json. Call this guy the object file. obj test.json. That's the name of my file. And then I can say y equals json.load s of the object file. Remember, I copied and pasted that stuff in there. From my dictionary format. Byte or a byte array. So does it want me to have double quotes around it? Or single quotes around it, I guess. See, this file I shouldn't have to have in a special format. Oh, it's just called load F. I have this load string. Okay. So I don't need to have these single quote things around it. And inside this, it's called load for the object file. There we go. So this loaded it as a dictionary. So if I say fname, it gives me the first name from that file. All right, that makes some sense. So for your homework, and I'll put that code up as a sample. So homework for Wednesday, update the map text file to be in JSON format and update map builder to work with JSON format. Note, you will no longer need to deal with the things being in a specific order. Note, you will want to look at how collections in JSON work, since our exits are a collection of JSON objects. That's the opening and closing square brackets, which I mentioned up here. So you can find examples of that online. You'll basically have opening square bracket, an entire exit object, a comma, another an exit object, a comma, another exit object with a closing square bracket on the end. So this allows us to have collections of things as opposed to however many I end up finding like we have in our current setup. All right, so I will give you this code as a starting point. I'll post up our JSON text file as well as the code that operates off of that. And then this is the homework, and I will see everybody on Wednesday.